Hi all, so this is from exercise 1 of our second topic in 2021 in term 1. And I'm just going to go through all of these exercises during this video as revision. So the first question over here says list the first 5 multiples of these numbers, and you'll see that I've just put them in there. It's 5, 10, 15. The reason why we start with 5 is because 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is, and I'm sure you get that. The next question asks us to write down in numerical order all the factors, so not just the prime factors of the following numbers. So I'm going to do 75. And 75, the first factors are going to be 1 and 75. 2 doesn't go into 75 nicely, so we ignore that. 3 does go into 75 nicely, so we'll put that down. 3 goes into 75 25 times. We'll put that there. 4 doesn't go into it nicely. 5, however, does go into it nicely. 5 times 15 will give us 75. I'm not sure if we have anything in between there, but let's see. 6, no. 7, no. 8, no. 9, no. 10, no. 11. Okay, so our factors are going to be, if I write them out nicely, 1, 3, 5, 15, 25, 75. And now I've made the answers for the factors of 40, and the factors of 54 magically appear. 1 times 40 is 40, 2 times 20 is 44, times 10. Sure you get the idea. And over here, 1 times 50, 2 times 27, 3 times 18. And I'm sure you get the idea there as well. So let's just erase all of that so we can make space for the next question. Question 7 asks us to express 1155 as a product of its prime factors. And you can use the ladder method or the tree method. I am personally going to use the tree method over here. And if I divide 1000 and all that by 5, I'm going to get that over there. And now I'm dividing by 3 to get 77, and after that I'll divide by 11 to get 7. So my prime factors are going to be 5, 3, 11, and 7. I must write them in numerical order, so let's do that. It's going to be 3 times by 5 times by 7 times by 11. There we go, products of prime factors. And let's move on to the next one, where we have to express 399 as a product of its prime factors. Just so that I've got a variety, I will do this as a ladder method. So I'm dividing by 3, and that will give me that number, and then I'm going to divide by 7, because that will give me 19, and 19 is also a prime number, so that means 399 can be written as 3 times by 7 times by 19. Now the next question is quite interesting because it is expressed 36 times 399 as a product of its prime factors. So this is what we do. We take 36 and let's divide it by 3, and that'll give us 12. And let's divide, I'm going to divide by 2, it's always easier, so that gives me 6. Divide by 2, that gives me 3 and 3 and 1. So 36 is going to be 2 squared times by 3 squared, which means 36 times by 399, I'm writing the answer underneath, is going to be 2 squared times by, and over here I have 3 squared and I've got another 3, so that means I've got 3 3's that are being multiplied by themselves or by each other, and There's the rest of the answer. So I've had to take the two numbers, 399 and 36, and combine them to make that as a product of its prime factors. Let's just erase everything else before we go on to the next one, which also asks us to write 84 as a product of its prime factors. So I'm going back to tree method. Variety is the spice of life and all that jazz. I am just rushing through it so that we can get there. Okay, so 84 can be written as 2 squared times by 3 times by 7. The next thing they're wanting us to do is 168 squared. Now there is a clue there. Because they've asked us to do, oopsie, I wrote 81. Let's change that to 84. Because they have asked us to do 84 before we did this, means that we've got to link the two answers. Now I know that 168 is the same as 84 times by 2. So I could write 168 as a product of its prime factors like this. But what if I were to square it? In other words, I am multiplying it by itself. That means over here, I'm also going to be multiplying it by itself. I see I've made a boo-boo. Here we go. I'm throwing in an extra 2 over there. The reason I'm throwing in the 2 is because 84 times 2, I'm throwing in another 2. There we go. So now I've got 84 times 2 times 84 times 2. Let's make that work over here. 2 cubed times by 3 times by 7, which would give me 2 to the power of 6 times by 3 squared and times by 7 squared. Let's erase that to make space for the next one. There we go. Steve and Ian are asked to find 60 as a product of its prime factors. Steve begins by writing 60 is equals to 5 times 12. Ian begins by writing 60 is equals to 6 times 10. Work out a final answer for Steve, work out a final answer for Ian, and express 48 as a product of prime factors starting in 2 different ways. Okay, so I'm doing tree method and I'm starting with Steve, where it's going to be 5 times by 12. 5 is a prime factor already, so now I am going to continue with Steve's method until I get to the point where it's going to be 60 is equals to 2 squared times by 3 times by 5. Now Ian is also my dad's name, but he is starting off with 6 and with 10. Because 6 is not a prime factor, we can still divide it up into, well, a prime number, into 2 and 3, and 10 is going to be 2 and 5. So 60 as a product of its prime factors, according to Ian, is also going to be 2 squared times 3 times 5. What they're wanting to point out here is that it doesn't actually matter what you divide by first, as long as you carry on trying to find the prime factors as you go along. Question 10b is not really linked to the top two, but it is linked in a way that they're wanting to show that we can calculate 48 as a product of its prime factors in 2 different ways. And that means we could have started with 48 and let's divide it by 4, which gives us an answer of 12 over there, and 4 of course can be 2 times by 2, whereas 12 is 2 times by 6, which we can then split up into 2 times by 3. So 48 as a product of its prime factors is going to be 2 to the power of 4, 2 to the power of 4 times by 3. If we were to start with other numbers, let's start by dividing by 2. That would give me 2 times 24, And then let's be wild, and we'll divide by 3, which gives us 8, and then divide by 2, which gives us 4, and divide by 2 again, and we get 2. So that means, according to that, 48 is also equal to 2 to the power of 4 times by 3. And that's the purpose of this question, to show that even though you're dividing by different numbers, you're still going to get to exactly the same output. The danger with word problems is that words can put us off. We like having just abstract problems. We don't have to think too much. But over here, we're told that Harley needs to put a fence of 26 meters long in his garden. Fence panels come in those widths. Harley wants to use the same width of panel. Which width panel should he buy to fit the length exactly? Now, there really is only one complicated part to this, and that is remembering that you need to change 26 meters to be in centimeters, because otherwise trying to convert those into meters or whatever, it's going to be difficult. You have to have them in the same units. Always easier to do it this way. After that, you're going to see if 175 centimeters can go into 2,600 without any decimals, and the same with 200, and the same with 220. Now, just looking at this, I can see already it's going to be 200 because it goes in nice and equally. 2,600 divided by 200 will give me 13 panels. And there's a lesson here. Sometimes you don't need to do lots of maths to figure out what the answer is. Look at the numbers and the question and the context of the question, and sometimes the answer just jumps out at you. Okay, let's erase that, because the last question is find the largest number apart from 840. That is a multiple of 24 and a factor of 840. So I have played with this a little bit, and I've got the prime factors over here of 840, and they are 2 to the power of 3 times 3 times 5 times 7. In other words, these are all of the numbers that can go into 840 and how they go into it in different varieties. And 24 is 2 to the power of 3 and times by 3, and as we can see, those two are common. Now, that means we just have to figure out, are we going to multiply 24 by 5 or by 7 to find the highest number that they're looking for? So let's do times 7, because that just works. So 2 to the power of 3 times by 3 times by 7 is going to be 168. Let's write that properly, which will give us the largest multiple of 24, which is still a factor of 840, because 840 can be divided by 168. What's interesting is 2 to the power of 3 times by 3 times by 7, or times by 5, would also give us a factor of 840, and it would be a multiple of 24. But they are asking for the largest number, and that's why we've chosen that one. And that's the end of exercise 1, star. Hello, lovely ones. So let's get going with exercise 2, star. And most of it is going to focus on finding the highest common factor and the lowest common multiple all over here. So the first question asks us to find the highest common factor and the lowest common multiple of 12 and 18. 12 is 2 to the power of 4 times by 3, 2 to the power of 2 times by 3 squared, and 18 is just 2 times by 3 squared. If I'm going to do a Venn diagram, which I am, I'm going to write each digit individually, and I'm first going to do it in their separate parts. The reason I do that is because it's then easy for me to see that those two are common. So I'm going to cross them out as if they never existed. And this 3 is common as well. Cross those out as if they never existed. So now I have a 2 left over on this part and a 3 left over on this part, and neither one of those are common. And let's erase those funny scribbled out things so we can actually see what's going on. Now the highest common factor is the intersection between the two circles. There we go, it's a good word. So highest common factor is going to be equal to the 2 times by the 3, which would give me an answer of 6. The lowest common multiple is going to happen when we multiply everything together that's in the union. And you can think of a union kind of like marriage. Once you move in with each other and have all the legal stuff and everything that happens with marriage, you kind of everything sticks together. There's that saying, what's yours is mine and what's mine is also mine. It's kind of like that. So lowest common multiple is then going to be 2 times by, there's another 2, times by 3, and times by 3. We could write that as 2 squared times by 3 squared, which is the same as 4 times 9, and that's going to be 36. Right, so with question 2, I have started it over here where I found 30 as a product of its prime factors using the tree method, and 105 as a product of its prime factors, also using the tree method. You'll see that I've left a funny little gap over here because I want to show you an alternative way of doing highest common factor and lowest common multiple. Now with highest common factor, we are looking for things that are common. And I can see over there that we've got 3s that are common and 5s over there that are common. So I could cheat a little and I could say that the highest common factor is 3 times by 5 because they both have those. So that's 15. Now the lowest common multiple, sorry it's going a bit all over the place in terms of formatting at the moment. Lowest common multiple would be to make sure that I have got everything represented over there. So that I have a 2 represented over there. And now you'll see I need a 3 because both of them contain 1 3 multiplied by itself. I also need a 5 and I need a 7. So the lowest common multiple is going to be the answer of 2 times 3 times 5 times 7, which is going to give us an answer of 210. So this is an alternative to the Venn diagram method. I find it's easier to use it if you write down the numbers underneath each other so that you can clearly see that the 3s line up and the 5s line up, making it easier to find highest common factor and lowest common multiple. Question 3 starts including geometry, so variables. I mean, not geometry, algebra. So they're variables, and you'll see that those carry on going all the way to question 7. Now once again, there are 2 different ways we can look at these that we're exploring. We could say, and this is question 3, we've got 3 and we've got x and we've got y, and over here we've got 2, y and z, and then we go through and we look, we've got y that is common but everything else that is not common. So let me just get rid of those. So our highest common factor will be y, but our lowest common multiple is going to be 3, whoopsie, sorry, that's so ugly, times x times y times 2, and then that other one is actually a z. So that is going to be 6x, y, z. The other way we could look at this is we look at 3x and y, and I'm spacing them out on purpose, 2, y, and z. Just like with the previous question, now I can see what's common. So the highest common factor, for some reason I'm still in blue, but the highest common factor is going to be that, the y, and then the lowest common multiple is going to be the 3 times the 2 times x times y times z, which of course gives us 6xyz. At this point, it's really important for me to note that we write our variables in alphabetical order. It's just easier to follow, it's easier to find like terms and all of those things over there. So these are the two methods you could have possibly used. Let's go to question 4. And 4xy is the same as 2 times 2 times by x times by y. 6xy is the same as 2 times by 3 times by x times by y, and that means the highest common factor are going to be the things that are common. Let's take a look. We've got 2 that's common, we've got x, and we've got y, so our highest common factor is going to be 2xy. Our lowest common multiple is going to be a number that represents everything we see over here. So it's going to be 2 times x times y, oopsie, y, and that gives us everything that's up over here, and now we just have to throw in what's missing over there, and that's the times 3. So let's times by 3, which makes it 4 times 3 is going to be 12xy. So now I've set up question 5 and 6 and 7, showing what I need to do. I've written things as products of their prime factors, but I've also expanded it. So rather than saying 2 squared, I've said 2 times 2. And I've spaced it out in a funny way so that it's easier for me to see the highest common factor. Now, common factors are things that are common. So over here, I have an x that's common and I have a y that's common, so my highest common factor is going to be xy. Remember that when two variables are written next to each other, it means that they are multiplying. Now, our lowest common multiple is when we include everything that is over there. So we have, if we look at x squared y, we have x, and y. I'm going to start by writing that down, x, y. Then at the bottom I've got an x, but as you can see I've already included one x. Then I've got a y, but as you can see I've already included one y. The only addition I need to make is that z. In other words, the lowest common multiple is x squared y z. You'll see over here that x squared had the highest power value, the exponent. Then y was the same on both, and z was magically there. Okay, question 6, I've got x to the power of 3 times y, and then I've got x times by y to the power of 4. And I've expanded them over here, and the only reason I've done that, in other words, you don't have to do that, but the only reason I've done that is because it makes it easier for me to teach how to find how to find the highest common factor. And the highest common factor, the ones that I've just highlighted in blue, they are common factors that are found in both of those terms. Okay, but now the lowest common multiple, we have to make sure that everything is included. Another trick you can see is the things that are highlighted just help us out in general. Okay, so at the top we have x times by x times by x times by y. At the bottom we've already included that x and we've included that y. So by highlighting them I can see that they've been included. But we still need to include those other 3 y's, 1, 2, 3, which will give us x to the power of 3, sorry this is so untidy, and y to the power of 4. It is possible to just go straight from this over here to x to the power of 3, y to the power of 4, and you'll find that as you do this more, you'll be able to do that more confidently than you have been so far. Okay, 7 had these two numbers that I then found products of prime factors over here, and I wrote them out spaced so that I could then see that I have a common factor of 3, and there's an x, and there's a y, and there's a z. So those are my common things. Let's put them in. 3, x, y, and z. Okay, in terms of our lowest common multiple, I need to make sure that all of those numbers are included. Let's do the top first. 2 times 3 times x times by y times by z. Then at the bottom, I still need to include that 3 that we haven't highlighted, and that y that's also not highlighted, and the z that is not highlighted. Really, I say this often, but I can't emphasize it enough. Highlighters are important. They really, really help to learn concepts, and I highly recommend you use them. So now we have x times x, and that's x to the power of 2. We only have those. Then we have y. How many y's do we have? There's 1, and there's 1, and look over there. We've got y to the power of 2. And lastly, how many z's do we have? We have 1, 2. There are 2 z's being multiplied by themselves. Now this question over here, I've written all of the numbers as products of their prime factors, going across so that I can once again just highlight what is common. I can see that all of those 2's are common. Then we've got a strip of 2's again, but then 3's start happening, so let's do that. There's a 3, there's a 3, there's a 3. We don't have any more 3's that are common, so I can see that. Do we have any 7's that are common? No, we don't. So our highest common factor is going to be 2 times by the green 2 times by the yellow 3. Now to do the lowest common multiple, I'm going to change things up a little over here. And rather than writing them expanded, let's do 2 to the power of 2 times by 3 to the power of 2 times by 7. And underneath we've got 2 to the power of 4 times by 3 times by 5. And underneath there we've got 2 to the power of 2 times by 3 to the power of 3 times by 5. And this will be useful when we're doing our lowest common multiple. The first thing we see is that we've got 2's happening everywhere. The highest power for 2's is 2 to the power of 4. So I know in total I need to have 4 2's multiplied by themselves. Then I can see I've got 3's everywhere, and the highest power for 3 is over here in the last line where it's 3 to the power of 3. So I need to write that down over there, and then I see I've got a 7, but I also have some 5's, so let's write down 5 squared first, 5 squared, and then I've got the 7 happening over here. Now in an ideal world we would be able to do this whole thing in our head. However, I don't think that's really reasonable to expect of you, so I would leave it like that, or I would use a calculator to find the final answer, and that's only because there is so much going on there. Now for the question 9, you'll see that I've chosen to go with the Venn diagram method again. And I have written the highest common factor as a product of its prime factors, and the lowest common multiple also as a product of its prime factors. The reason I've done that is because then I can put those common factors, or these things, so the 2 squared is common, 3 is common, and the 7 and the 5 are common, and I'm going to put them in here. So I've got 2 times 2 times 3 times 7. And that is called the intersection, and it has a value of 84. Now the rest of it that's left over here, I've got 5 and I've got 11, need to be distributed in the one circle and the other circle. So let's just make this easy. I'll put the 5 there and the 11, sorry, not the 7, over there. And I'm going to tick off to show you. I put the 5 over here and I put the 11 over there. So let's find out what the two numbers are. The first number is going to be everything that's included in that set over there. I have got 5 times by 2 times by 2 times by 3 times by 7. And my second number is going to be 2 times by 2 times by 3 times by 7 times by 11. The way I got that was I multiplied all of those together. And I must be honest, I'm going to use a calculator to figure those ones out. Well, there we go. I used my calculator and I found the two numbers were 420 and 924. Question 10. A new school is deciding whether their lessons should be 30, 50 or 60 minutes long. Each lesson duration fits exactly into the total teaching time of each school day. How long is the longest teaching time of each school day? Could there be more than one answer? Give a reason for your answer. Now, this one's really interesting. Could there be more than one answer? And you've got to think of break time there, because break time could give us different answers. But anyway, let's look. A new school, we're going to be working in 30s and in 50s and in 60s. Now, if we were younger, we would have done common multiples and carried on going until we found something that was common amongst all of them. But we're older and uglier, so we're not going to do it that way. We're rather going to write it as products of its prime factors. So 30 is going to be 2 times by 3 times by 5. Then 50, I have to work this out quickly, 50 divided by 2 is going to be 25, and that's going to be 5 and 5. So 50 is 2 times by 5 squared. Then 60 is going to be twice of 30, so that means, there we go, times by 3 times by 5. So our lowest common multiple is going to be, if we look at the 2's, we have a 2, we have a 2, and we have a 2 squared, so we have to have 2 squared. Then I see that I've got a 3 over here, I've got 3 over there, both of them are to the power of 1, so I put a 3 as part of my answer. And lastly, I have a 5 squared and a 5. Let's put that there over there, and then I'm going to work it out. It's going to be 4 times 3, which is 12 times by 25, and this is equals to 300. Now remember, that's in minutes, so 300 minutes is the total teaching time of each day. Could there be more than one answer? And yes, that comes from break time. What's happening at break time? The other thing is, how much time is 300 minutes? Because maybe we want to have more than 5 hours of school. That's how much 300 minutes is. Maybe we want to have 7 or 8 hours. So there are a whole lot of things that we could be taking into factor over there. It all depends on what's going on. And we've got the last two questions of this exercise. We've got Tom and Harry, who are racing go-karts, And Tom finishes 1 lap in 128 seconds, which can be written as 2 to the power of 7, whereas Harry is 120, which can be written over there. Now this is talking about the lowest common multiple, and if you were younger, you would have written a whole lot of multiples like this, 256, blah, blah, and then you would have as well done this until you found something that was common amongst the two lists. But we're older and uglier, so now we don't have to do that. To find the lowest common multiple, we just need to make sure that everything is included. So we've got 2 to the power of 7 and 2 to the power of 3. We need to include all 7 2's. There's 2 to the power of 7. Then the 3 and the 5, and when we multiply that all together, we get an answer of 1,920 seconds. Now remember, we still need to divide that by 60, so that means we're going to get 32 minutes. And that's what the question's asking: when will they next cross the start line together? Question 12. Fatima is preparing food parcels to give to charity, and she's got all of these things. Each food parcel must contain the same number, and there must be nothing left over. What is the greatest number of food parcels she can prepare, and what will be in each parcel? So over here we have all of the numbers that we've got to include. And I was a bit of a chop because I wrote lowest common multiple rather than highest common factor. And that's what we're looking for. We are looking for the highest common factor to find out how many bags we're going to fill. And let's take a look. We've got 2 to the power of 1. Then we've got 3 to the power of 1, and we've got 7. So I'm just going to highlight that over there. Whole lot of highlighting happening in funny places. So 2 times by 3 times by 7, all of those can go into that, which makes it 6 times 7 is going to be 42 bags. So how much can go into each? Well, all we need to do then is divide 254 by 42. And then I should have said 252, but oh well. And then the other one by 42, and the last one is going to be 294 divided by 42. And those give answers of 6 and 4 and 7. That means in each one there will be 6 tins of beef, 4 chocolate bars, and 7 packets of soup. I personally think it should be swapped around so that there is more chocolate in each. Anyway, that's the end of exercise 2 star. Happy learning. Well, let's begin with exercise 3 star, which focuses on ratios. First question: divide 350 pounds into the ratio 1 is to 6. Now, part of the problem with this question is that it's all in maths talk. So we've got to think about it as, what is the statement 1 is to 6? We're talking about 1 part to 6 parts. And those parts, when added together, are going to equal the whole 350 pounds. So that means how many parts do we have in total? We have 7 parts. Okay, if we're talking in terms of maths, it means we need to divide 350 by 7 in order to figure out that 1 part is going to be 50 euros and 6 parts is going to be 300 euros. Now, you could be very fancy with the way you show this, and you could show that you're increasing the ratio like this and all sorts of things like that. But to be quite honest, as long as you show something, even if it's just drawing a picture, it's good mathematical procedure. The only thing that is a definite no-no is that you don't show anything. You have to be able to explain the calculations you did. The next question, a type of cat food contains chicken bones and chicken pieces in the ratio of 20:7. So that means for every 20 grams of chicken bones, there are 7 grams of chicken pieces. What is the weight of the chicken pieces needed to make 2 kilograms of cat food? Okay, so I'm going to write down the ratio, 20:7, and it's talking about parts again. I've got 20 parts to 7 parts. So how many parts do I have in total? 27 parts. Now in terms of the weight, I'm going to change it to grams, so it's 2,000 grams, and I need to divide that into 27 parts. And I am a little frustrated because the answer comes to 74,07 blah 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 rather than a nice number. But anyway, we've got 74 grams and we need to do 74 grams times by, what are we looking for again? The weight of the chicken pieces, that's going to be times by 7 then, and we will get an answer of 518 grams. So not a great answer because of the decimal space, but oh well. Okay, the next question says divide 576 tons into the ratio of that. Now if we were younger and more innocent, the question would have been something like divide 576 sweets into the ratio of blah blah blah, and it would have brothers and sisters names, just to make it feel more familiar. It's exactly the same question though, it's just not looking very familiar. So let's do that. We've got the ratio 4:3:2. So if we were doing sweets, we would know that when they're handed out, someone gets 4 sweets, then the next person gets 3 sweets, and the last person gets 2 sweets. Now we need to figure out, based on that, how many sweets each person would get if there were 570 sweets in total, except we're working with tons. So that shows us we need to figure out how many parts there are. Well, it's 4 plus 3 plus 2, that's going to be 9 parts to that. In other words, every time we're handing out sweets, one round of handing out sweets is going to be 9 parts. The maths then is to do 576 divided by 9, and that is 64. So each part is equals to 64. If we want to figure out the ratios, we're going to go 64 times by 4 and 64 times by 3. Lastly, 64 times by 2. Let's put the colons there. That is 256, 192, and 128. So in terms of the tons, if we were to divide them up, we'd get 256 tons is to 192 tons, which is also to 128 tons. Question 4 contains a whole lot of words that I cannot pronounce nor have I ever heard of. But basically it's asking us to take this ratio 2:3:25 and figure out how much of these vitamins with the funny names will be in 10 milligrams of the serving. Now, here is the ratio. I've written it out. 2:3:25. And you'll see that I've put the 10 milligrams underneath it. And I've done this purposely because it helps me now to introduce how to do ratio calculations. I know that 2:3:25 gives me 30 parts. I need to increase that in the consistent ratio, so by the same factor, to get to 10 milligrams. And in order to do that, I'm going to divide by 3. So that means every single number over here, I am going to divide by 3. And the great thing about high school mathematics is I can just write it as fractions. So I'm going to go 2/3 is to 3/3, which is to 25/3. And I can simplify if I want. However, it doesn't go much further. 2:3 is to 1 is to 8 and 1/3. The question's not finished though. Calculate the amount of that one in a bowl of cereal. Okay, that one's in the middle, and we know that that is equals to 1. So that means it is 1 milligram of this. And ideally, once again, you would write this into a nice sentence that would include all sorts of fancy words. But let's go on to question 5. On Saturday at 12 p.m., that's noon, there were 45 staff members and 375 customers in a department store. Write the customer to staff ratio in the form as n is to 1. Okay, the question says 45 staff members to 375 customers. What's important to notice is that the ratio they want is customer, which is 375, to staff, which is 45. So the customers must go for first and the staff afterwards. The nice way of working this out quick and easily is to just use fractions immediately. And you make it 375 over 45 is to a ratio of 1, which of course means that it is 25/3 if I simplify, and that is to 1. So that's question 5A. 5B, another department store has 70 staff members and 637. So we're going to do the same ratio as, same order as before, and we're going to do the same calculations as before so that we get it into n is to 1, and 637 divided by 70 is going to, when simplified, be 91/10 is to 1. Now what will make this easier to see is I've got 9 and 1/10 is to 1, and with the question before I had 8 and 1/10 to 1. So in this case there are less customers to each staff member, but however NB, which store has more customers than staff members, that's going to be the second one, because there are 9 and 1/10 of a person to each store person. I don't know how you get 1/10 of a person. Maybe you cut off like that much of their body, so they've just got half a head left. But anyway, that's a discussion for another time. One of the problems with giving mathematicians word questions is sometimes what they write doesn't really make sense. So question 6, Cheryl and John both make hair dye by mixing hair colorant with peroxide. Cheryl uses that much colorant and that much peroxide, but John uses different amounts of colorant and peroxides. Who has a greater concentration of peroxide in their hair dye? So I have written the ratios of colorant is to peroxide for both Cheryl and John. Question's basically asking us to simplify the ratios so that we can figure out which one is best. Now, one of the ways to simplify is to go n is to 1, or we could go 1 is to n, or we could just see what happens when we simplify them by the same amount. So let's start by just simplifying. I know that both 750 and 450 can be divided by, let's write it in red, 150. So if they're both divided by 150, we're going to have the ratio of 5 is to 3. In a similar fashion, we can simplify John's amount by dividing both by 15 or 50, and that gives us an answer 17 is to 13. The problem is at this point is we can't figure out which proportion is better just by looking at it. So we're going to have to use one of these other measurements. Either n is to 1 or 1 is to n. This question says who has the greatest concentration in peroxide in their hair. So they're looking for peroxide. I put colorant first. So there is peroxide per unit of colorant. So I actually want to have the 1 first and then the n, because the 1 is going to be the per unit and the n will be that. Okay, so in order to do that, I am going to do 3 over 5, and over here it's going to be 13 over 17. And if I write these as decimals, it will possibly be easier to see what it is. And I think it is, because we can see that there is a higher concentration of peroxide per unit of colorant in John's mix. The next question says, Jackie and Alan share the profits of their business in the ratio of the amounts they invested. Jackie invested that much and Alan invested that much. At the end of it, Alan gets that much. How much did Jackie get? I really like this way of writing down ratio calculations. So the first thing I'm going to do is write down the original amounts. Alan is second, so then I will write down his new amount over here, which is £18,000. So he went from 150 pounds to £18,000. We need to know what's happened to 150 to make it 18, so that we can do exactly the same thing over there. And we can do that by dividing 18,000 by 150, and we find that we're multiplying, let's do that in red, we're multiplying by 120. So if we're going to multiply the other side by 120 as well, I will get an answer of 20, let's do it in black, 20,400 pounds. So then I would write a beautiful sentence saying something about Jackie. The last question for this exercise says, to make concrete, Ali mixes 2 parts of cement with 5 parts of sand. Write down the ratio of sand to cement. Order matters. So if it says sand first, then we put sand first and cement second. B says to lay the foundations for an extension. Ali uses 60 kilograms of sand. How many kilograms of cement does she use? Okay, so if she is using 5 parts, so now it becomes 60. What have I done to 5 in order to get to 60? I've multiplied by 12. So that means I am also going to multiply the 2 by 12, which gives me 24 kilograms. And once again, I'll write a beautiful sentence. C. On another project, Ali uses 75 kilograms of cement. How much sand did she use? So remember, we are using the ratio 5 parts of sand to 2 parts of cement. We're told that it's 75 kilograms of cement, and we need to figure out how much sand she used. Let's once again figure out what we do to get to 75, and by doing that I do 75 divided by 2, which gives me 37. So I'm multiplying by 37.5. That means on the other side I'm going to multiply by exactly the same thing. So 5 times 37.25 is going to give me 187.5 kilograms. So it's important that you then write a beautiful sentence about it. And that is the end of exercise 3 star. Well done. Welcome to exercise 4 star, which is a revision exercise on everything we've done recently. Question 1 asks us to express 1008 as a product of its prime factors. And you'll see over here, I've done that using the tree method. So I divided by 2 and got 504, which I divided by 2, and you can see as it goes along. So that 1008 is equals to 2 to the power of 4, because 1, 2, 3, 4 2's are being multiplied by each other, and 3 to the power of 2, 1, 2 3's, and then there's a 7. The next question says find the highest common factor and lowest common multiple of those 3 numbers. And I've taken a moment to write down all of these as products of their prime factors. The highest common factor is whatever is shared amongst them. So I can see that each one of these numbers have at least 1 2, and they have at least 1 3. Not all of them have a 5, not all of them have more than 1 3. So that's why those are the only highest common factors. The lowest common multiple is where we make sure that we've got representation from every single number over here. So yes, there's going to be a 2, but there will be 4 2's that are multiplied by each other, because that includes everything. For that reason, our lowest common multiple is 2 to the power of 4. There it is. And 3 to the power of 2, because there it is. And then, of course, we've got the 5 hanging on at the end. Now, question 3 says 2 numbers have a lowest common multiple of 432. And you'll see that I've done the product of prime factors over here. Then the highest common factor of 72 I've also done, and I've put them into a Venn diagram so that I can see the intersection is going to be 2 to the power of 3, 3 to the power of 4, which is where, 3 to the power of 2, which is where the highest common factor happens. And that just leaves me with a 2 and a 3 to deal with. And I can see that I've been a bit of a chop there. That should have been written as 2. So that means that my 2 answers are going to be, the one of them is 216 and the other one is 144. So I've got those multiplied by each other to get to this answer over here, and these ones multiplied by each other to get to that answer over there. Question 4 asks about 3 lighthouses that flash their lights in different intervals. One flashes every 15 seconds, the other one 20, and the last one 45. They've all just flashed right now. We need to figure out when they're going to flash next, and the answer is 540 seconds. The way I got that was I first looked at everything as products of their prime factors, and then figured out the lowest common multiple. Then that was 2 to the power of 2, 3 to the power of 2, and 5. Multiplying those all together, I got 540 seconds. The next question asks about Erin, who is busy making bouquets, and she's got 75 pink, 105 yellow, and lastly 45 white roses. She wants to figure out how many bouquets she can make with an equal number of roses. In other words, she's looking for the highest common factor. So once we've written everything as products of their prime factors, we write down the highest common factor, and that gives us 15. The next part of the question asks what will be in each arrangement. So I'm taking each type of rose, 75 pink roses, and dividing them by the number of bouquets there are. So 75 divided by 15 gives me 5 pinks, 7 yellow roses, and 3 white roses. The next part of the question asks about the London Bridge and the scale model. So the scale model is 66 meters for every 22 centimeters. If we reduce it, we find that 1 centimeter on the model represents 3 meters in real life. So that's the ratio we've got to. Now the next part says the bridge is 243 meters long in real life. How long is the model? Well, we've got to take the 3 meters and turn it into 243 meters. And whatever method we use there, we've got to use the same method on the other side of the ratio, which means we're multiplying by 81. Okay, and that's it for now. Enjoy!